Hello and welcome to our final lesson, our final topic for this module, which is solving quadratic inequalities. So before we get to the inequalities, I just want to recap a little bit and show you some connections, okay? So we started, I think it was back in module 1.5. I don't know. It's been a little while. We looked at a module where we were factoring quadratic expressions like x squared plus 5x plus 4. In this case, factors of 4 that make 5 would be 4 and 1, and so this thing factors into x plus 4 and x plus 1. Now, factoring an expression for the sake of factoring an expression, not super helpful. The reason we wanted to be able to factor the expression was so that when it was in equation form, we could solve. So these are the factors. If we took this equation, same expression on the left, and factored it into x plus 4 and x plus 1, then those factors would show us the solutions. So we can tell just by looking at this equation that negative 4 would be a solution, and that negative 1 would be a solution. Now, if we look at quadratic functions, or look at the same expression, but now we stick it into a function format instead of the equation format, what does it give us? Okay, so if I wrote this function in its factored format with the x plus 4 and the x plus 1, well, now we can see the roots. The roots are the x-intercepts. If I put a 0 in for y, and I said what values of x are going to make the equation equal 0, then we're looking for the same thing, the solutions, right? Those solutions end up showing me the roots for this function. So, goodness. If I put a 0 in for y and solve, I get the same solutions that I had in that second box there. So this, we can tell, this factored form is going to have roots at negative 4, 0, and negative 1, 0. Okay, sorry. So the factors of our expression, those show us, they help us find the solutions to our equation, and the solutions to our equation happen to also be the x-intercepts or the roots of our function. Okay, the related function, which means it's got the same expression, it's just a y equals instead of an equals 0. And that got a little squished. Okay, so therefore, because the factors show us the solutions and because the solutions are also the roots, we have a lot of different names for roots, x-intercepts, so I've been using a few already. So we use the words, we use the words solutions and x-intercepts and roots and zeros. We use these words interchangeably. When I say we, I mean people in the math world, okay? So when you're finding the solutions to your equation, it's the same thing as finding the roots for the function. And because those roots are where the graph crosses the x-axis, or because they're what makes the function value, the y value, equal 0, then solutions, x-intercepts, roots, zeros, all asking for basically the same thing, so all used interchangeably, okay? So we see connections now between the expression, the equation, the function. And now let's look at an inequality form of our quadratic. Inequality meaning we're going to have a greater than or a less than or greater than equal to or less than equal to instead of the equal sign. Okay? So solutions to quadratic equations, what we just said, the solutions to the quadratic equations are the exact values of x where the related function intercepts the x-axis. Okay, so here's our same function. This was y equals x squared plus 5x plus 4, same function. If I said, where does this function equal 0? It's going to cross the x-axis here. What are the solutions to the equation? That's where are the roots of the function. So we would say that this thing is equal to 0 at this point. No, I gotta get, sorry. At this point and at this point. So it's equal to 0 at the places where it touches the x-axis. So at x equals 4, which is the coordinate. Sorry, that's a negative 4. X equals negative 4, which is, I can't fit it. Okay, bear with me, people. Sorry. X equals -4, which is the coordinate -4, 0, and at x equals -1, which is the coordinate -1, 0. Okay, now, if instead of asking you where the function is equal to 0, then I want to know, if I want to know where is it less than 0, what do you think that means? If I said, where is this function, where is it less than 0? Well, if equal to 0 is on the x-axis, it's what makes the y value equal 0, then less than 0 should be where the y value is less than 0, meaning where is it below the x-axis, okay? So below the x-axis is what this is asking for. Where is it less than 0? That is, where is it below the x-axis? Well, this portion of the graph is below the x-axis, and that corresponds with these x values between -4 and -1. So there's a whole set of solutions for this inequality, which is generally what happens when you solve an inequality, right? When you solve an inequality and you get something like x is greater than 2, that means all the values greater than 2 are in the solution set. We have a solution set here, a whole interval where values are going to work. So this would be from -4 to -1, all the stuff in between there, and not including the -4 and the -1, because those points are equal to 0, not less than 0. So we want to keep parentheses on the -4 and 1. So when we're solving a quadratic inequality, inequalities, solutions to quadratic inequalities are the intervals where the graph is either below, if it's a less than, or guess what, if it's a greater than, above. Okay, or either below or above or below our x-axis. So here now, if I said less than or equal to, now it means it can be below the x-axis or on the x-axis. So my interval is still from -4 to -1, but because now I also have the equal to, here, I would use brackets to say, well, we can be on or below. So this is on the x-axis. This is strictly below the x-axis. This is on or below the x-axis. Okay, now where is the function greater than 0? Where is that quadratic greater than 0? Greater than 0 is going to be above the x-axis. So this portion is above, and this portion is above, and this first portion here corresponds with all the x values before -4, and the other portion here corresponds with all the x values that are after -1. So this is saying, where is our graph above the x-axis? And it is above the x-axis over two intervals. The first interval being from -infinity up to -4, not including the -4 because we're strictly above, not on. And then from -1 to infinity, everything after -1, again, not including the -1. Now, if I make it greater than or equal to, then we can be on or above. So if we are on or above, then we have the same interval, or intervals, but now we can include the x-intercepts. So if we are on or above, if we can now equal, then we're just going to replace those parentheses on the -4 and 1 with brackets. So we have still a -infinity, it's a -4, but now we can include the -4. And then again, we can, I swear, I said blue. We can now include the the -1. Okay, so if we have the equal to in there, then we can include. So just be careful with those. And let me just change these colors so they kind of coordinate. Equal to is on, equal to, nope, that's horrible. That looks a little better, maybe? Okay, so equal to is on, less than is below, greater than is above. Okay, so if I already gave you the picture, it should be pretty easy to identify your solution sets or your solutions if you're looking for the exact solutions. But what if I just gave you the function and I said, hey, where is this function greater than 0? Where is this one less than or equal to 0? Well, if you could make your own picture, then you could just as easily as we did in the last few come up with your solution set. So what you want to do, it just depends on if you're doing this by hand or with your calculator. By hand, these are all going to be doable because I put all factoring examples in here. So you can find the roots to sketch a graph. You can do that by hand, or you can graph using Desmos. Either way is going to be totally fine. I'm going to show you both. And then basically just determine the appropriate intervals based on the symbol. Are we looking above, below, or on, or both? So remember, greater than is above the x-axis, less than is below the x-axis, and if we have an equal to in there, then we want to include the points on the x-axis. Okay? So, for example number 1, if I factor this, factors in -30 to make -1 will be -6 and +5. So if I was looking at the related function instead of the inequality, then it would have roots at 6 and at -5. So in my head, I already basically know what this graph is going to look like. This is going to be a parabola that opens up because there's a +1 out in front, and I know where it's crossing the x-axis. So I'm just going to sketch this out. It's crossing at 6 and it's crossing at -5, and it opens up, and I don't really care what the rest of the parabola looks like for the purposes of what I'm doing here. I just need to know exactly where it's crossing the x-axis and which way it opens. So I know it's opening up and I know where it's crossing the x-axis. Now, the question was, where is it greater than 0? So where is it above the x-axis? Well, this portion is above and this portion is above, which means everything before -5 and everything after +6 is going to be included in my solution set. So my solution set, actually sets here, are going to be all of the x values from -infinity to -5 united with all the x values from 6 to infinity. And because we don't have an equal to there, we don't want to be on the x-axis, we strictly want to be above. We're keeping parentheses on the -6 or -5 and the +6. Okay? Not so bad. Now, if you wanted to use Desmos, you could absolutely do that. So you could just graph your function, x squared minus x minus 30. So if you didn't want to make your own picture, then you could look at the picture on Desmos and you could see the same thing. Everything from -infinity to -5 and everything from 6 to infinity is above the x-axis. Okay? So I prefer to do it by hand, but you know, if you don't want to take the extra step of factoring, then don't. But I'm going to do that here just so you have good thorough notes. So 2 times 2 is 4, and factors of 4 that make 5 are 1 and 4. Dividing those by 2, we can see this is going to factor into 2x plus 1 and x plus 2. So the related function here is going to have roots at -1/2 and -2, right? -1/2 and -2. So if I was to sketch this graph out at -1/2 and at -2, we're crossing the x-axis, so -1/2 and -2, and I don't even care that this isn't like spaced out accurately. It doesn't really matter. It's going to give me enough here. And this parabola, because there's a positive out in front, is again opening up. So it's going to open up and it's going to pass through those 2 points. Okay, so that's basically what this parabola is going to look like. So now the question is, where is it less than or equal to 0? That is, where is it on and below the x-axis? So this portion here, which corresponds with these x values. So my solution set here, solution set, one set here, includes everything from -2 to -1/2, and it also includes the -2 and 1/2 because we can be on or below. Okay? Alright, let's try another one. This guy, if we were going to factor, we would take the negative out first. So that would be a positive 15x and a positive 56. And so then it's going to factor into an x plus 7 and an x plus 8. And again, if I was looking at this function, it's going to have roots at negative 7 and at negative 8. So negative 7 and negative 8, and again, I don't care that this is not spaced out correctly, but I know it's going to be crossing at negative 7 and negative 8, and sorry, I just realized those are going to be in my way. And this parabola opens down, opening down because there's a negative out in front. So it opens down and it goes through these points, or whatever. That's basically what the picture is going to look like. Now we can use that to answer our question, which is where is this greater than or equal to 0? That is above or on the x-axis. So this piece is above, so these x values correspond with that section of the graph. So this solution set, now I have to move this because it's too squishy. This solution set is going to include the values from negative 8 to negative 7 and negative 8 and negative 7 because we can be above or on the x-axis. Okay? All right, one for you to try if you're feeling comfortable with this. And by all means, if you don't want to make the graph by hand, use Desmos. But I'm going to go ahead and factor this thing. So take out the negative. That's 3x squared plus 2x minus 5. And factors of, let's see, negative 15 that make 2 would be 5 and negative 3. Dividing by 3, we can see this is going to factor into 3x plus 5 and an x minus 1. And so if we looked at that function, it's going to have roots at negative 5/3 and positive 1. So if I was to sketch this graph out, it's going to open down because we got the negative out in front, and it's going to go through these roots. We have one at negative 5/3, and we've got another one at 1. Again, I don't care that it's not proportional there. But it's opening down and it's going through those roots. So there's just a really basic sketch of what our parabola is going to look like, which, again, you could have done that in Desmos, would have been totally fine. So now the question is, what color did I use over there? Where is this? Just above the x-axis. Above the x-axis is that interval there, not on, just above. So we're looking at these x values. So our solution set goes from negative 5/3 to positive 1 and will not include those intercepts because we just want to be above the x-axis. Okay? So now that we've got that established, let's see. They've got a couple of special cases I want to make sure that you're okay with. So if we look at this particular example, x squared plus 4 does not factor. Okay, but we should still be able to graph that because it's a transformation of our parent function. This is the parent function, and this would just make it shift up 4, right? So even though this doesn't factor and I can't see roots, I can still graph. If I was to graph this function, it's going to shift up 4, and it's going to open up from there, right? So this is the picture. So if I said for this particular example, where are we greater than 0? Well, this entire graph is greater than 0. This entire graph is above the x-axis. So this solution set includes all real numbers. Solution set includes all real numbers from negative infinity to infinity. Okay? Or you could have said all real numbers is there as well. Now, if I had said where is it less than 0, then there would be no solution, and that's exactly what's happening here. So this is the same graph. Okay, same graph, shifted up 4, opening up. Okay, where is it less than 0? One of these days, guys. Okay, where is it less than 0? Well, none of this graph is below the x-axis, so there is no solution set. No solution set exists for this particular problem. Right? There is no solution or solution set. okay, for this, because none of this graph is below the x-axis. And I guess we can say a little special note on this one. The entire graph is above the x-axis. And then here, none of the graph is below the x-axis. Okay, so there are these special cases where everything is a possibility or nothing is a possibility. So I'm pretty sure I put some of that in your practice. So give it all a try. And again, if you don't want to factor or do any sketching by hand, you can use Desmos to look at the graph. But in either case, what you're going to want to do to solve a quadratic inequality is look at the graph. The graph is going to tell you exactly where you're above or below or on the x-axis, so you're going to have to read the graph to figure out the solution sets for these quadratic inequalities. Okay? So you've got some practice to work on, but as always, if you need some extra help, just reach out. I'm here for you. All right, guys, take care.